Hi everyone, my name is Kimga Claire and I'm going to be taking you through the timetable generator, part 5. Uh, start, I'll start with the contents of the presentation. It's actually going to be a short video and I'll talk about heat maps, correlation matrix, box plots, future independence plots, outliers, illustration of patterns of interest, illustration of trends in time and space, clean data, split the data, train it, and more of that. So allow me to take you through. I'll start with heat maps. First of all, heat maps are graphical representation of data that utilize color-coded systems. Like we get a way of representing our data using different colors, like to simplify work, how colors really tell through pictures. So this is an illustration of a heat map that I generated using the data set that I'm using. So this heat map shows the connection between the student ID and the course ID. And wherever you're seeing that one diagonal, like it shows how the course ID really maps to the student ID. For example, in the first column, the student ID maps to the student ID, so that is a positive high correlation, and that's why you're seeing there a 1. So to go down in the same column where you're saying 0.072, we are relating the student ID with the semester ID, and it is a positive low correlation. That's why you're saying 0.072, and so on down like that. Wherever it maps the same value to the same value, like student ID to student ID, we get a positive high correlation. And for the heat map, they represent the correlation using the same colors, like the same colors. If it is student ID with student ID, they put the same color, like it's here it's gray. And if it's course ID with course ID, still you can see that it's the same color, even for year semester and year semester. To take you through the correlation matrices. So a correlation matrix is simply a table which displays the correlation coefficients for different variables. And this matrix displays correlation all, like between all the possible pairs of values for the table that you are given. It just summarizes everything and give you a view, like you visualize patterns of the data in also color codes. So this is the correlation matrix for the timetable generator. It's simply, this is the code, how we generated the correlation matrix for it. And we just put in the plot function dot title, meaning we are plotting according to our title for the different columns that we had, and generated the correlation matrix for it. To go to the box plot, mainly the box plot, it gives you a standard way of displaying the dataset based on minimum, maximum, the average, median, first and third quartiles. Like when we have a given dataset, for example, we have given values, for example, student IDs. So for the box plot, it helps you to give the boundaries of the data. Like our data mainly is composed of this. This is its median, first and third quartile, like this is mainly on the median, first and third quartiles to give the output. So for the data, for the box plot, we use student ID and the weekend, like how do students attend lectures during a certain week. And for Monday, Tuesday, Thursday, and Wednesday, students were attending lectures, like their attendance was uniform, though on Saturday it dropped a little bit and it resumed on Friday. It resumed on Friday, then on Saturday it dropped really, like students don't really do Saturday lectures. So the future independence plots, also the future independence plots, it simply shows how is this value independent from the other one, but what is the correlation of their independence, like how do they correlate. So The green color, it simply shows the year semester. Then the pink, it is the course ID. Yellow, the student ID. Like, how is the year semester relating to the student ID? How are they different? This shows that different students, for example, for the course ID with the students, many students, okay, students are mapped to the course ID because students really do a variety of course units, but still the number of students that do a certain course correlating to the course IDs, like they are not uniform, like different students do different course units. That's why the growth is like that. So we go to the outliers. Outliers, mainly these are like it's a scatter plot, the point or points that are farthest from the regression line. For example, if to say that the regression line is drawn based on this, for example, the student ID, or okay, let me take the course ID. So for different students do different courses. So you can find that you have a class that has, for example, 100 students who do the same course units, and some 50 maybe, but the class doesn't do some course units. So the 50 now become our outliers, those people that are within the same class, but they don't do that same course unit. So the outlier really bases on that. Then the illustration of patterns of interest. Here it generates different graphs basing on the student ID and the course ID. And those are the graphs that it generated. Illustration of trends in time and space. Here we consider time as a factor, and we consider the student ID, year semester, the course ID. We use this because the way they like the numeric data in our data set. So it was showing the correlation, like at minimum, at standard deviation, how do these theory correlate? We see they have a very high correlation at minimum, almost their mean was the same, and the standard deviation, but there is a great difference when it comes to the 50% and 75%, like they scattered a lot, though the student ID and the year semester at maximum, their graph tends to behave in the same way. So I'll take you through also how to build an end-to-end machine learning pipeline. Machine learning pipeline helps to automate machine learning workflows by processing and integrating data sets into a model. And we're going to be following these steps, mainly data ingestion, processing, splitting, model training, model evaluation, model deployment, monitoring, model performance. So to go on, explore and clean data. Here we are dealing with clean data after you've got your data, maybe from different sources like cargo. You have to clean data, like to see are there some null values. So our data had some missing information, which we solved and we removed. As you can see the output of before and after. This had missing info, but the other one doesn't have it. So we cleaned the data. Splitting the data, splitting mainly we are dealing to, we want to split data to get a different set of data for training and another set for testing, and we splitted our data, as you can see. So further on splitting and validating data, that's what we did. Like we got a particular segment of data and we separated it for training and the other one for testing. To fit any one initial model, actually, model fitting is a measure of how well a machine learning model generalizes to similar data to that on which it was trained, like the data that you trained it. So if for it generalizes that once you give it this information and you've trained it, it can do another sort of like same stuff on a different information package. That's it, mainly to fit. Then hyperparameter tuning. Hyperparameter tuning is an essential part of controlling the behavior of machine learning model. Like it helps in controlling our machine learning model, and it consists of finding sets of optimal hyperparameter values for learning algorithm while applying this optimal algorithm to any data set. Mainly, yeah, that's it. On the evaluation of the dataset. Machine learning pipeline helps to automate machine learning workflows by processing and integrating datasets into a model and which can be evaluated and delivered. Like we want to evaluate our data. Like if you have managed to train it on this given set of data, can it really do more? Like when you give it a different data set that like a different data, let me say package that we've not trained it with, can it produce the required results as we expect it to produce? Because we should have trained it to 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 deal with the same data but of different ways. Yeah, mainly this is what I had for you. Thank you for watching. You can subscribe for more of this timetable generator. Bye bye.